Howdy everyone, this is Pragati Arumugam Udayakumar. Today I'll discuss milestone 1 for the course Advanced Data Management ISTM 622. The table of contents for today's presentation is listed in the slide. We'll start by discussing use case. Professor G gave us the Ethermart's use case for creating database schema. Ethermart is an e-commerce platform which sells cutting-edge technological products, and it is following a multi-channel operational model, which means it sells its products through e-commerce websites, through its standalone mobile application, and through pop-up retail partnership in major tech hubs. What this essentially means is Ethermart acquires its data from various resources, and thus it might not be uniform or synchronous. So our key deliverables for this project is to create a robust MariaDB infrastructure which is capable of storing a logical and normalized database schema, and we should implement automated data ingestion techniques such as ETL and ELT, and apply advanced SQL features for data cleaning. And the important thing is we have to automate every repetitive task through scripts. So the first step in this project is to create EC2 instance. Professor G has asked us to create AWS EC2 Ubuntu instance for this project, and he has also provided an automated script for MariaDB, which will install MariaDB while the instance is getting created itself. I have tweaked this script to include Ubuntu user creation and MariaDB user creation while the instance is getting created. This will enhance security so that rather using root user to perform all the operations, we can perform the allocated user. So if you see the snippet, I am creating both Ubuntu user David Miller. David Miller is the data architect of our use case, so I'm going ahead with that name. And I'm also creating MariaDB as David Miller, and I'm giving a password as ISTM 622. And in the next slide, I am validating the operation that I did before. MariaDB, I'm checking if MariaDB is installed. Yes, MariaDB 11.8.3 version is installed. And also you can see David Miller is listed as one of the users in the MariaDB. So the second step is data generation. I have explored 3 techniques for data generation using Python code. So the first step is through FileZilla. So in this method, what we'll do is generate our Python code in JupyterLab or any other IDE and save the CSVs in our local, and then transfer the files from local to our EC2 instance through FileZilla, which is a third-party tool. And the second step is utilizing Google Drive. So we can upload all our CSVs inside this Google Drive and then get the access link by setting the access as public. And utilizing this wget command, we can clone these CSV files from Google Drive to EC2 instance. And the third step is utilizing virtual environment. We can create a virtual environment inside our EC2 instance, which will allow us to install Faker library, which is utilized by the Python code, which is used for data generation. And then after that, we can execute the Python code and generate CSV file inside the virtual environment itself. I am finally proceeding with the third technique because it will allow me to generate the data inside the EC2 instance itself, and thus eliminating the need for me to transfer the files between local and EC2, and also it streamlines the workflow. So this snippet is where I'm creating a virtual environment, activating it, installing Faker inside virtual environment, and then generating the data generating Python code. And you can see all the CSVs are successfully created and stored. And one important thing to note here is inside the root user itself, I'm executing the ls command, and you can see all the CSV file are inside the root user also. Even though I generated the files inside virtual environment, it is also accessible inside my root folder, which is helpful for me to perform MariaDB operations. And the third step is database table and view creation. So I have developed an automated script which will ensure database creation and table creation for all the 7 CSVs that Professor G provided, and also view creation. This view will consolidate the order and product details of the e-commerce platform. So this is a small example snippet of how I created database, and then how I created tables inside those database, for example the customer table, and then loaded the data into the customer table. And this is the ER diagram that I have used to create this database schema. You can see customers, orders, products, suppliers. These are the primary entities since this is an e-commerce platform. And also you can see there is many one-to-many relationships in this ER diagram. What one-to-many relationship means is, for example, take this customers and orders. Multiple customers, for every single customer, they can place multiple orders. But for every single orders, there can only be one customer related to it. So that is what one-to-many relationship is. And in this diagram, you can see all the 7 CSVs that Professor G gave us. Also, I have created a new table, supplier contact, because suppliers table is not atomic. So what atomicity is, basically, for a given cell in any table, the data inside it should be atomic. It should be singular. So if you see the contact email column in this table, there are multiple emails stored inside a single cell as comma separated values. So this doesn't comply with the first normal form of database. So what I'm doing is creating a supplier contacts table to store the email address and then referencing this with the help of a foreign key of supplier ID. So this is the code of doing it. So I am creating suppliers table and I'm giving supplier ID and the supplier name as the columns in it, and I have omitted the email email column in this. And then in the supplier contacts table, what I'm giving is supplier ID and contact email, and setting this supplier ID as the foreign key which is referencing the previous supplier ID. And to perform this action, I am creating a temporary supplier contacts table which will store all the email IDs as single row as comma separated values. And then I'm going through all the rows of this temporary supplier contacts table and parsing as delimiter as comma, and this n into n basically means run it n times as the number of row times, and it is parsing every emails and storing it as a single row inside the supplier contacts table, so that I can ensure atomicity in suppliers table as well as supplier contacts table. And this is the snippet in which I am executing my automated SQL script, which contains database creation, table creation, view creation, everything all together. And I'm executing this my SQL Ethermat SQL with MariaDB command. And you can see this is the validation that all my tables have been successfully created. And this 110, these numbers demonstrate the number of rows in every table. So yeah, this has been validated. And the last step is data cleaning. The data provided to us was not, it had many abnormalities, including the data had many null values and it was not unique. And also the date formats was not uniform. Some had date, month, year, some had month, date, year. It has to be uniform while storing it in database. And also I removed the extra space and encapsulating codes for text fields. And I ensured atomicity for every tables, which I discussed in the previous slide. And one important thing is I have provided offsets for every primary keys. For example, the tables products, orders, order items, for these the primary key did not start with 1. It started with 1001 or 101. So in this case we have to perform a offset management so that we won't face any issues while accessing these tables and foreign keys. So explain this in detail. I'm taking products table as one of the example. So the cleaning processes that I have performed is, you can see I have given primary keys and foreign keys, as well as I have given not null for the product name, because this is a product table and the product name should not be null. And if you see category ID and supplier ID are the foreign keys. Thus I'm giving data type as big int unsigned, which matches with the serial of the primary key. And also one important thing to note here is alter table products auto increment is equal to 101. So if you see the right hand image, this is the CSV of product table and the product ID is starting from 101 and not 1. So we have to when we give serial, it automatically starts from 1. So we have to set the offset as 101 so that whenever a new row is inserted, the data is inserted as 101, 102, not 1 and 2. And yeah. So the last data cleaning that I did was state formatting. So this is the code for date formatting, in which I have used regex expressions to compare compare the existing date formats against these types of date formats: year, month date, year, etc. And if it complies, if it goes through any of this if statements, then the data will be converted to the date format of SQL, which is year, month, date. And if it doesn't comply to any of this, null will be stored in the record. And AI disclosure, I have utilized AI to understand the concepts of how to clean data, and mainly to perform date formatting, and also to perform atomicity. So I inferred data from AI and then incorporated my own knowledge to implement the logic. So yeah, this is the end of the presentation. I hope all of you guys understood and liked it. So please give me a good rating. Thank you.